Okay, you saw this thumbnail, and what is it? It is interstitium, which is nothing more than skin or the layer that coats your intestines or whatever. And then just below it, in every single organ and every part of your body, your skin, your eyebrows, everywhere, there's a flexible fabric layer so that you can squish around and you can push your tissue back and forth. And these little balls anchor this in to this fleshy area so that your skin can come back to wherever this was. The skin, to a certain point, doesn't have any of these balls. And then at a certain point, a whole batch of them show up. Now, what is this that we're looking at? That is nothing more than what you're looking at up here, only it's now geology. At one time it was biology. And that was a mucosa, which is either the skin or the wrapping of your membrane or whatever it is. And just below it is the anchors that make it come back to where it's supposed to be after you stretch and move and pull and reach. It comes back because these are anchored in that flesh. This is just eroded away from the waves beating up the guy's body. And it's some creature. These balls are covered with algae or some form of biology that's living on there. They fell out of this wall, which was the interstitium layer, and that is the layer of skin. Now, the white cliffs of Dover, all over that. I'm going to show you all of these things in a minute. I just figured I'd catch you with the eye grabber. Now we're going to get in, but first we're going to look at Carrara marble, because it is nothing more than this. But marble and limestone and kaolin clays all have an origin that is very similar. It only relates to a couple of little molecules, and they're in, like calcium and magnesium, the same period on a periodic chart. And they bond a little bit differently with other things that are in your body, in the creature of bodies. Because this is nothing more than stabilized body tissue. That's all it is. At one point, this would have rotted if it was out in the air. Well, at some point, this had to be... And the only thing I could think of was there was this great flood they talk about. It was an extremely salty, saltwater, long-duration flood. And Velikovsky, who did the research on what was written about this flood, said it was a hot water flood. And the hot water was because we almost got impacted by Venus, I believe, and it took 7 days of intense radiation as it approached the Earth. It literally boiled the oceans and the rivers. People tried to save themselves, but they boiled in the waters in a lot of places. I don't think every single place, but maybe. And well, some people lived, and I don't know whether they lived I don't know exactly how they got through it, to be perfectly honest with you, if it was as bad as they said, because it said they had, at the brilliance of 1,000 suns, it boiled the waters, it combusted the atmosphere, methanes and gases and plasma and all kinds of things fell on the Earth from the interaction of the particles, basically, almost like just being bombarded with asteroids. And at that point, the actual condensation of our atmosphere took all the oxygen out of our atmosphere, recombined it with the hydrogen, and turned it back into water. That's condensation. Condensation. That almost hit us. It condensed, and then they said it was written in the text that there was, and of course they had all kinds of fires and volcanoes. The Earth was wrenched. It was burnt, it was scorched, it was all that. And they said they didn't hardly have enough oxygen to start fires for years after that. Because there was just no oxygen in the air to make, adequate combustion. So the Earth repopulated itself from oxygen. I mean, there's so much to learn here. It's just staggering. And we're going to go through it in pretty good detail, right? Well, not in extreme detail, because the detail goes on and on and on and on. So little is understood, as you will see. Uno momento. Okay, my outstanding friends, this is going to be fun. This is Earth from Space, Carrara, Italy, where they get all the top quality marble. And I'm going to show you something. I'm going to try to explain to you that I don't think they understand what they're getting here. Now, this is from the European Space Agency, and they're showing this stuff from space. And this came from my good friend Pedro, who was with the European Space Agency. Now, they're going to come out here, and this is a mountain range, stretches 55 kilometers. And it's a mountain range. Mountains, way up high. Remember that, way up high. We're talking mountains. Now, why is that important? This is where they're mining. Okay, again, this is European Space Agency. This is where they're mining all this marble. You see that little red stripe in there? People that understand mud fossils will understand about the redness, and it's going to be here and there, just little bits. Now, why are they mining up so high here? This is famous for its marble. All right, now marble, I'm going to try to explain to you how marble is formed, because it's limestone, marble, kaolin clays. They all have a similar origin, and it depends on the chemistry that they're in, the pressure, the heat, all of that business causes different chemistry in a similar layer. So you might have a little extra magnesium, a little extra calcium, extreme amounts of silicon dioxide, and there's all kinds of chemistry for these different. Marble's not just marble here and marble there, it's all the same. No, absolutely not. You can know exactly where marble came from by its physical content. Absolutely 100%. Pinpoint it to a local region. No question whatsoever, because of the concentration of elements that are in that marble. And why are they different in other concentrations here than other places? Because the chemistry here is different, because the biology here is a smidge different. And I'll show you the biology. This is biology. This is not just rocks that's formed from sedimentation that collected in pools and formed limestone. This is on the top of mountains. This is not, they say this is all sedimentation and all formed and then compressed, and it's on the top of the mountains. They never think about what they're saying. I mean, it's unbelievable, the statements that are made about geology. It's a disaster. Okay, I'm just going to let her speak as they show this, and I'm going to cut in here and there.
Bright white marble, contrasting with Tuscany's lush green vegetation. The white or blue-gray Carrara marble...
All right, first of all, you see these little cracks here, and you see what's leaking out of them? Why is that leaking out of there? Why are these? These are blood vessels. These are tiny little blood vessels, and there's very few of them in this very, very fine skin, which at one time was fine skin. Now it's turned into marble. It transitions. She'll talk about it, and they're somewhat right. Here goes. But I believe it's more related to the exact chemistry that was here and not necessarily to pressure and so forth. But here goes.
Is one of the most prestigious marbles in the world, with its quarries producing more marble than any other place on Earth.
Now don't forget, we're way up high in the mountains. And again, listen to what she says. It's amazing.
The unique stone was formed by calcite-rich shells.
All right. She's going to talk about these being marine sediments that drifted down to the bottom and then turned into marble because they were calcite shells. That's not true. Now, let's see all these black stripes. What the hell is going on there? Why are we having all these black stripes up there? Why? Well, I know why, and I'll show you another place where they are, and I can show you exactly why they are there and what they're doing there. And that is blood running out of layers of tissue. So here we go back to what she's saying.
Stone was formed by calcite-rich shells, left behind by marine organisms when they die. When water bodies evaporate, the deposited remains form limestone, and when buried under multi-ton layers of rock, the intense heat and pressure cause the limestone to metamorphose into marble.
All right, let's just talk about that. Marine organisms settle to the bottom when they die, is what she says. Well, no, I understand that. Why is this on the top of the mountain? And then once they get buried, then they have to be layered on top of something. Where's the stuff that's layered on top of it? It's completely contrary to what the statements are. I know exactly what this is. I can show it to you. This is biology. The whole earth and literally everything I can find is biology. And I will show you what this exact same stuff is and where else it's located in the world. And this is going to pop your cork, my friends. Now you can see the whole distance here. It's all layered. And boy, I'll tell you, this stuff is fertile. That is really grows a nice, very lush green vegetation. Okay, my friends, the evidence is everywhere. These are the White Cliffs of Dover again, and these you can see are obviously some form of layers. And I know what they are. They are tissue layers, and there is so many layers of tissue in your body, you have no clue. And this is another shot of it, and you can see all the layers. I mean, there's no question. Now, they start to get tendon balls down in here, and there may be some up in here too. I'm not sure what this black stuff is, but you will see, as I showed you in the other one, it will be at some point these attachments that make your skin come back to where it's supposed to be. You have a very thin layer of skin that has no real attachments, but underneath that's glued to a layer that has all of these balls and straps that make you come back to where you're supposed to be. So this is a very, very big creature. Okay, this is over in the United Kingdom somewhere. I think Huntington's Beach or somewhere. But you see how the black balls start to form right about in here, and then they really get dense down when you get into the red layer. Now, the White Cliffs of Dover is huge up here. This layer appears to be below the surface of the water. And what this has done is eroded all this stuff and all these balls, which are these balls right here. And all that mud ran out because this was actually at one time this stuff, which is interstitium. And that means that you have the layer of skin, or sometimes it's mucosa, which is the layer of, like in your intestines, and it's a membrane layer. Let's just go with that. And then below you have all this floppy stuff that lets your skin go this way and that way and push up and down and move. And this layer just sort of glides with it, but these bring you back to where you're supposed to be. This is what eroded out of Huntington's Beach there. And all the balls drop down, and you see all that red flesh, and it's because the water has eroded away. And the top is the mucosa. That's the skin layer, and I'm telling you, it's skin. And it's not just one layer. There's literally probably 1,000 layers of skin before you hit the interstitium, and then there's another 1,000 layers there. I'm telling you, it's just unbelievable. It's unbelievable, and I'm working with some of the top fascia specialists in the world. I'm going to be on a show, I don't know, a week or two, with Gil Headley, who is probably, as far as I'm concerned, in gross anatomy, which is the full features of the body. He's probably the best in the world. And I worked with him for 10 years, not really worked with him, but I asked him a lot of questions, and he answered my questions very nicely, and I watched his videos, and because he does actually autopsies on and he shows you all the stuff that's inside the creature's body, human body, and he is in the process right now of doing a project on all of the tendon and bone and muscle insertions into your body, because it's different everywhere in your body. Your chest is different than your legs, your feet, your hands, your toes. Everything has a different lock-in, and then it has to transfer there to a tendon, and sometimes it doesn't go to a tendon, it goes right to muscle. Sometimes it goes right to bone. And he has to figure out all of this stuff. Nobody really knows this stuff. I'm telling you right now, this is a wide open area right now for anatomists and autopsy people, because they really don't know much about the human body. I'm telling you, they don't. This has only been discovered, this layer here, I swear, only been discovered about 3 or 4 5 years ago. I'm not kidding you. I've been working with this layer for 10 years with Gil, but they didn't realize what its significance was until just a few years ago. They never saw it before. By the time the autopsy people got it, there was no fluids in here. All of my stuff is just like it was when it was new. I can see all these balls. I can see all those fluid-filled bags. I can see everything. Just like you can see them in that wall. It's all still there. They missed it all because by the time they get to the autopsy, it's flat as a pancake. All right, so and this has been rediscovered just recently. Now, this was from a video called 12 of the Most Things They Can't Explain. I could explain every single one of them. These little mouse balls, they call them, I think I can't really remember what they call them, but they're all coated with very, very vibrant green, mossy looking stuff. And that is what grows on biology as it becomes available as nutrition for these plants. They love this stuff. They're all over. You see up here, way up in the back here. They're everywhere. This was another gigantic creature. And they're everywhere. It's not just here. This is just the ones that are eroding. They have them in the desert too. They call them the Moki marbles. You see them, they're everywhere. You see when I told you there was a zillion layers? You see these? This is kaolin clay, kaolin clay, whatever you want to call it. It starts with a K, but kaolin clay is what I call it. Now, you see how many layers there are on there? That is skin tissue. This is all ground up kaolin clays. You see that? Nobody knows how many layers of skin there is. These are layers of skin. This is kaolin clay. Every layer of there is a tissue of layer of skin. Nobody has any idea how many layers of skin there is. There is literally thousands within like almost no distance whatsoever. This is magnification 24,000 times. This is University of Jordan. So that's the kind of skin tissue. Nobody understands it. You know, I mean, they look at it and they can understand it, but they're looking at clay and they don't understand that is your body tissue, because they just didn't even understand interstitium until not too long ago. So this is just, they can't understand this relates to the body of a creature. It's just kaolin clay to them. And I would ask any chemist or any geologist or any biologist to tell me why there would be so many layers there. What are those layers doing there if they aren't biological? Why? All right, kaolin clay comes in various shades of skin colors. That's exactly what they are. I'm just telling you, this is just unbelievable, but it's true. The creatures that were on this earth were just absolutely, nobody can get their mind around it, so don't worry about it. You know, just calm down and take it easy. It's all right. It just happened. I can't explain it. There's a lot of thinking to do and a lot of ancient texts to look through, because they talk about all these things that we're discovering now. Very, very interesting time to be alive. All right, I hope you can see that. That's a blood vessel. And that is in kaolin clay. The guy's got in his hand, it's a piece of kaolin clay. And that's just a blood vessel. And they all have them, but very, very few. You really got to search to find the blood in the kaolin. All right, this is the kaolin clay again. You see how many layers there is there? All of those are skin layers. They are not just there by accident or from sedimentation. And that ball is there not by accident either. That ball is there because it's a tendon ball, and it had a little stub just like that one did, only it broke off. It was coming out of here. And they all have straps. And again, I'm doing a show. Let me just show you quickly what we're going to be doing. All right, I'm just going to show you a real quick little video in a second. But what Gil's going to be talking about is all of these different types of tendon emplacements, which you have to lock stuff in, and those are the anchors, and these are the balls, and then the straps go out, and there's ligaments, there's tendons, there's entasis, there's muscles, there's bone attachments. All of these things he's going to talk about, and they don't really understand them that well. Gil probably is the one that understands them best in the world, because he's actually digging into the body. Now, I see him in their absolute unbelievableness, because I'm going to show you a tendon assembly, the whole thing, from where bone implants to the tendon to the muscle to the glue, everything about it, right in my mud fossils. And we'll actually see it, not like in an autopsy. And an autopsy is pretty gushy. But let me just show you what Gil's about to say. Okay, I'm pretty sure I mentioned I'm going to be on a show with Gil Headley. He's really top shelf fascia anatomist, well, gross anatomist. He does all of it. Autopsy guy. Now, I say that these are biological, and we're going to be going over this exact situation where you have a bone implant, and exactly which bone this is, I do not know, but it certainly is a bone, and then there's a gluey substance right there that actually attaches this little tendon segment to the muscle, and the muscle literally weaves in. I don't know if you can see that or not. You see that? It actually weaves right in. And I'm going to show you a better picture of it when it first came out of the ground about 10 years or more ago. It was nice and fresh. You could see all the blood and everything. Like right up there, you see that layer? Let me back out of here. This is the external layer. And this is really scratchy sand. I mean, this is as sandy as sand gets. And it's really like sandpaper. Then you get a layer of absolute raw blood. And then you come down into the tissue and the muscle and the tendon and the bone implant. And we'll be able to see all these fibers and all of this stuff in there. Because I have the microscope going here. Well, I don't have it going right now, but we will be getting into the microscope. And we will be looking at that stuff in great detail. Because you can actually see the glue. And I can show you the exact same tendon fibrils in this that are the ones that are in Baalbek. I'm not kidding you. Wait till you see it'll blow your mind. And I'm going to do this in a whole nother video because it's a little intense. Because we're going to go through, Gil is going to talk about different types of attachments, because this is bone to muscle, muscle to bone, bone to perifascia, bone to subperifascia, all kinds of things. And he has gone through the entire human body and found every different type of attachment and how they attach and what they attach to. And and I think he's probably the only one that I know of in the world that has a good understanding of this. There's other people doing it. There's only a few other ones that are really top shelf at it that I know of anyway, but I'm sort of outside of that loop. But I know Gil is right up on the top, and he's been on the top of my list for 10 years. He was the only one, well, there was two guys, him and Robert Schleif from Germany, that talked to me about fascia, and Gil was the autopsy guy, so he knew fascia in every intimate detail. And Robert was fabulous, but his main concern was sports injuries and rolfing and splaying back out the tendons so that they didn't cause pain and so forth. Anyway, we're going to get deep into this, but I want you to know, well, let me just show you this when it was nice and fresh, because you could see, what you're going to see is, when I do this in the microscope, absolutely going to blow your mind. All of these, you see all these abrupt transitions, all these tendon fibers. When you see it when it just came out of the ground, it's absolutely stunning, absolutely stunning. And there's glue in here. There's glue that glues the muscle to the tendon, to the bone, and that's exactly what Gil wants to go over. Or he's actually doing it. I may not wants to go over. He's going to show that in his video. This relationship of the pectoralis major, which is your chest muscle, and how that is a very evolved muscle. Anyway, we'll come back at this. The next video is going to be with Gil and I and my discussion of this and the different types of... I'm going to show this in a microscope. Let's just go with that. All right, this is that muscle that I showed you here that we're going to be looking at the microscope. This is when it first came out of the ground. I mean, the blood is just raw blood. That is actually literally an artery right there. And all of the blood that is supplied, this whole layer of blood, just eroded out of here. Blood is very fluidy. And this is the connective tissue. This is the tendon. There's going to be glue right in here. And the bone implant is up here. I didn't show it in this picture. But you can actually see all of the different fibers and everything in here now. And then down here, this is what they call abrupt transitions, as the muscle turns into more muscle instead of fibers. Back here, you see, remember I showed you it's locked right in there? And this is more of a tendon. There's a little, I'll show you when we get to the next one. And Gil will be talking about it as well. Okay, so you've seen my muscle here, and I have another one over here I call Muscle Mountain. It's just a smidge bigger than mine. And what do we see? We see all of that red blood running off. We see connective tissue overlapping and weaving. precisely as it does in our living creatures that are roaming the earth today. So, it's time to have a whole new outlook on what we thought. And just re-examine it. Maybe we were right, maybe we were wrong. Who knows? All right, I can't help myself. I got to leave you with one last thought. You see all of these little layers in here? These are, every single one of those is a separate layer. You see them? That is a layer of skin. That's a layer of skin. That's a layer of skin. And I showed you this kale and clay. There's thousands and thousands of layers. This, I mean, just think of how huge this creature was. And this black stuff running out from in between the layers, the reason that's running out is because that is what's called synovial fluid. Synovial fluid. I don't know if you can see this. No, you can't here. Whoops. Yeah, let me back this out of here. In human beings, you have little slippery places. All your bones have to slide and move, and everything has to, your tendons too. It's called synovial fluid. Synovial fluid. Synovial joints have a coefficient of friction of 0.01. Teflon on Teflon is 0.04. Look at this. When you're stretching, Teflon stays at 0.04, and this goes to 0.003. The coefficient of friction of synovial joint fluids is just astronomically slick. And that's what's coming out of here, because every one of those layers has to do this. Every single layer in your body. And that's what Gil told me. He said when people get glued up, they don't move. That stuff will start to glue up. It won't have that 0.0003 coefficient of friction. So when you try to move, it'll go, and you just can't get it. That's what you got to be slick. You got to be as slick as you can be.